You seem crazy, why teach us math? Complex numbers are imaginary. You'll really like when we're solving problems. Quadratics are just a problem in graphical form. But because I'm mathy. Welcome everybody to 4.4 Complex Numbers. Today we're going to be writing quadratic equations in intercept form. What? And then we're also going to be solving quadratic equations by factoring, two of my favorite things to ever do. So let's move on here to our first, what is an imaginary number actually. So imaginary unit is defined as I squared equals -1. So if you have an I squared equals -1, well, where in the heck does this I squared come from? Well, we'll get to that in a moment. Your number I is the square root of -1. So what that means is if you have I equals the square root of -1, if you start off like that with an I equals the square root of -1, if you square both sides, well, that'll square the I, so you get an I squared. If you square a square root, remember that just gives you whatever's underneath. Oh my gosh, there it is. There are a couple rules you need to make sure you know. Okay, whatever's here, highlighted here and here. You need to know those. The reason this imaginary unit I was ever invented was because sometimes some mathematicians were getting negatives underneath their square root. We know that's not possible to get a real number. When we were graphing, and we found out that we got a negative underneath our radical, our graph did not cross our x-axis, which meant we didn't have any real solutions. So the opposite of real would be unreal or imaginary, just like a few of my friends. But we will not bring Cletus into this. So what we want to do here for example 1 is we first need to simplify this. So a couple different ways you can do this. You can look for perfect squares and to simplify. So what I look at first is I look to see if there's any factors of 28 that are perfect squares. Well, factors of 28 would be 1 times 28, 2 times 14, 4 times 7. 4 is a perfect square. Oh my gosh, that'd be great. So what we'd be able to do is this 28 would be able to factor into a square root of 4 times a square root of 7. Now what happens with this I though is it needs to come out, sorry, not this I, this negative. That is a square root of -1. Remember from up here, I, or if you have a square root of -1, that is an I. So what we're going to do is we're going to actually simplify this a little bit. The way I like to do it is I like to just bring out the negative as an I. It just turns directly into an I. And then what we have is a square root of 4, which is a 2. Square root of 7, well, we can't reduce that anymore. So what we get for our final solution is just a 2i radical 7. So that looks a little goofy just because we have that I, but that's really the only new part that's from Algebra 1, because you learned how to simplify radicals way back in the golden days of Algebra 1. When you're like, when am I ever going to use this? Well, you're going to use it here in Algebra 2. So what we did was, let's go back through this real quick. We took the negative out, where we wrote it as a -1, which in it becomes an I. Then we found factors of 28 that one of them's a perfect square, 4 and 7. That square root of 4 turns into a 2, square root of 7 just stays underneath. So another way you can do this is we can just simplify a -32, and the way we can do that is just by doing some upside down division. So I'm going to bring this negative out, and when it comes out, it's going to come out as an I, but we're going to have to simplify your 32. So another way you can do this is you can do upside down, or the factor trees. 2 times 16, 2 times 8, the 8 reduces 2 times 4, and 2 times 2. And this is helpful, the factor trees are real helpful because we're trying to find a square root, so we're trying to find any any doubles. Well, there's a double of 2, so that means we can bring a 2 out. We have another group of 2's we can bring out. So there's another 2. And this bad boy, well, he is left all by himself, poor guy. he is going to stay underneath your radical. So in order to simplify this, now what we need to do is we need to multiply whatever's on the outside. 2 times 2 times I. That's going to give us a 4i. And this radical 2, poor lonely fella, he's going to lay low and stay underneath the radical. So this is how you can simplify radicals.